Now that we have the root mean squared error number for our model, we can get the same number for other projection models out there on the interwebs. The other projection I'm going to compare against for this lesson came from the folks at Fantasy Pros who have some great stuff. I saved down their 2018-19 season projections for the NBA, and we will use them as a benchmark to see how we performed with our model. This isn't a contest, but merely a good way to show you how you can measure a model's performance. Let's first read in our CSV, which has all of our projections that I ran offline using our model. Now, the catch is our model used specific stat columns from the NBA Stats API that don't match up exactly to the Fantasy Pros projections, so we have to run simple math to make all things equal. Let's create a list with the projection columns we want first. So we'll create a columns equals list, and let's fill it with the columns we want. Then we can create a new data frame which only contains the projection columns and not the real stat columns, which are also a part of the CSV we read in. We can do this by passing the list and using our lock to slice it. So the player projected, the location, and again we want all the rows, and then just the columns we ran in that list. And let's save this to a df projection final data frame. Now, our field goal percentage and free throw percentage were never calculated since we had the raw makes and attempts. This means we can create these new columns by dividing the makes by the misses. Let's create a new column for each. So within our data frame, we can merely get the made field goal attempts and divide it by the projected field goal attempts. And here we will just save this and add a new column called the projected field goal percentage. And we can do the same thing for free throws. We'll just change our field goals to free throws made and free throws attempted. So this is now going to create a new column with projected field goal percentage and projected free throw percentage. We also split our offensive and defensive rebounds, so we need to sum these together to get our total rebounds. To do this, we just take our projected offensive rebounds and our projected defensive rebounds, and we can save this as a new column and just call it projected rebounds. So if we look at our new data frame, we'll see we have these three new columns. We can now create another list with our final columns that we will be using. Let's just call this the final columns. And this is going to be made up of the following statistical categories. And again, let's filter based on these final columns. Great. Now it's time to read in our competitor data, which is currently stored as a CSV. We will save this as a df competitor data frame, and again I'm reading in the ESPN CBS Fantasy Pros basketball overall projections, which I got from Fantasy Pros and is made up of various ESPN and CBS numbers. And let's just take a sample of the df competitor, and you'll see they have very specific column names. So after sampling, we notice that there are a few columns we don't need for this exercise. So let's drop these columns by creating a list with the columns to drop. So again, the columns to drop. And here, we don't need the team or the positions or the games played. And we can drop these columns and use our in-place parameter to update the current data frame. Again, by just saying we want to drop the columns, which are these columns to drop, and then in place equals true, which means we're just going to override our current df competitor. And we'll run this and take a new sample. And here is our modified data frame. Since we only have the player name, we are going to need to join on the name to get the player ID. Names can be tricky, so to help increase our chances, let's convert everything to a lowercase string. We can do this by taking the player column and using the string method, making sure to call lower. After this, let's update our player column with the new lowercase names. So let's create a variable lowercase names that takes our df competitor data frame and takes that player column. And this is where we're going to run the string and then make sure we call the lower method on it. And we can run that. And now our df competitor, the player column, we want to update this with our lowercase names that we just got above. So we run that. And now if we look at a sample, we'll see all of the names are lowercase. Great. Next we can read in our player info data, which has our player IDs and player names. We will need to run through the same exercise of converting the names to lowercase. Let's also filter using the 2018-19 season just in case we have more player rows. So again, our season, we just want the player info where the projected season ID equals 2018-19, and just give us the player df where the player info is filtered on that season, and our lowercase equals the player df of the player name column, and again string lower, and then we can update our player df player name column with the lowercase values we just saved. And just to get a sample of this, we see we have all of our lowercase names. Now we're ready to merge our competitor df with our player info df to add on player IDs. We will drop the duplicates and reset the index so we have a nice data frame to work with. We will do this using the pd merge method. And we're taking our df competitor data frame with our player df data frame, and within this one we actually only care about the player name and the player ID column, and how we are merging this as a left join. And let's just specify that left on equals player and right on equals player name. And again, we want to drop the duplicates just in case and reset the index. And let's save all of this as our competitor merged data frame. And to play it safe, let's also drop the rows with any missing values so we don't run into any issue with the mean squared error function. So we'll take our comp merged, drop na, how, if there are any, and we can just save this right to the same data frame. And again, we can sample this. Great, so now we have our player ID, but you'll notice it has a decimal. So let's actually look to see what the data type is for each of these. In here, we notice our player ID is actually a float, which explains why this has the decimal. We want to convert our player ID to an integer instead, so let's run the astype method on the column. So if we write player IDs, and let's get that one column with player ID, and then we're going to run the astype, which takes the data type we want, which is integer. And then again, we can go through and update our player ID column with the new player IDs. And now if we go look at the D types, you'll see it's an integer. Cool. At this point, we're ready to delete our player column since we don't need it anymore. We can do this by just calling the del on the column name. And we can update our columns and column names by passing the list with everything exactly how we want it. So to match the competitors, we are going to use player name, player ID, but then we have the points, reb, assists. All of this is uppercase. And let's just update our data frame with the column names by passing a list. And then we can get a sample, make sure everything is right. Awesome. Okay, let's now get our real data from the player projected data frame by calling the columns without the projection before it. Let's also get the player name and the player ID.